Sustainability is a fundamental component of the Air France-KLM Group strategy. We've been one of the leaders in the Dow Jones Sustainability Index for 16 consecutive years. Naturally, we aim to maintain this position. As part of our strategy, we've committed to make a significant contribution to the UN Sustainable Development Goals. These goals serve as a blueprint to achieve a better and more sustainable future. Amongst others, they include the goals affordable and clean energy, responsible consumption and production, and climate action. At Air France-KLM, we put in continuous efforts to reduce our environmental footprint, and notably, our CO2 emissions. We do this by developing more efficient aircraft, improving our operations and processes, partnering and innovating in the supply chain, and mobilizing our staff and the industry. The air transport industry is now working towards carbon neutral growth. No increase in carbon emissions in spite of traffic growth. This is the first step towards a carbon-free future. The two might seem mutually exclusive, but it is possible. One of the primary instruments to reach this goal is the usage of sustainable aviation fuel, or SAF. SAF. AFKL is one of the frontrunners in this area. So you might ask yourself, why do we need SAF? Well, the aviation sector currently accounts for 2 to 3% of global CO2 emissions that are produced by human activity. This amount is still small compared to other sectors such as ground transportation and large industries. But these sectors already have viable alternative energy sources and their relevant technologies, such as wind and solar technology. They allow for energy production with much lower CO2 emissions. And of course, these sources are constantly evolving. For aviation, though, there is no viable technology to power flights beyond sustainable aviation fuel. In other words, commercial aircrafts will, at least for the time being, continue to fly on jet fuel. These other sectors are therefore expected to become more sustainable at a faster pace than the aviation industry. So this means that if air transport continues to grow, and we don't take any action, we will see the industry's emissions continue to rise. In a few decades' time, global air transport may produce more than a fifth of all man-made CO2 emissions. So is there nothing we can do? Well, yes. In fact, the aviation industry has a basket of measures. Continuous improvements in aerodynamics of aircrafts, engine performance and flight operations will help the industry to reduce its carbon footprint. But even if there is significant progress, the efficiency gain resulting from these measures will not be sufficient to decarbonize the aviation sector. And this leads me back to why we need SAF. The development of SAF has been identified as one of the major ways to reduce CO2 emissions. The use of SAF can provide air transport with a near-term solution for a fuel with a lower environmental impact than conventional jet fuel. Now let's look at what SAF means. As you already know, SAF stands for Sustainable Aviation Fuel. Sometimes it's called aviation biofuel or biojet fuel. It's a cleaner substitute for Jet A1, the conventional jet fuel. And while Jet A1 is fossil-derived, SAF is produced with an alternative feedstock. Basically, feedstock is the material from which fuels are produced. Now, the characteristics of SAF are almost identical to those of Jet A1. SAF therefore meets all the technical and certification requirements as jet fuel and is safe to fly on. Fuels with these properties are so-called drop-in fuels. This means that they can be automatically incorporated into existing fueling systems without any adaptation necessary. Handy, right? So what makes SAF sustainable? SAF must, of course, meet stringent sustainability criteria to qualify as sustainable aviation fuel. These include substantial reduction in CO2 emissions. For its production, it may not require any materials whose use would have a negative impact on biodiversity. What is more, the production of feedstock for SAF may not lead to deforestation or fail with freshwater requirements. Therefore, the suitability of the feedstock for SAF is carefully scrutinized. SAF can be produced from different alternative sources, ranging from several kinds of plants to animal fats and used cooking oil. New feedstock sources are also being explored. To name but a few, municipal waste, agricultural and forestry residue, as well as CO2 itself could in the future serve as SAF feedstock. The sustainability of the chain is ensured through certification by the International Sustainability and Carbon Certification Plus, ISCC+. and the Roundtable on Sustainable Biomaterials, the RSB. So how can SOF reduce its CO2 emissions compared to Jet A1 fuel while their characteristics are so similar? It's a good question. During flight, about the same amount of fuel is burned, and an equivalent amount of CO2 emissions is produced. So it's important to understand that we achieved a reduction throughout the entire life cycle of producing and using sustainable aviation fuel. The source of the jet fuel is the most important difference. Fossil fuels release additional carbon that was previously stored in reservoirs. Sustainable fuel is made from biomass that has absorbed CO2 emissions from the atmosphere. The amount absorbed is roughly equivalent to the amount of CO2 emitted when the fuel is burned in a combustion engine. Therefore, the CO2 that is emitted when using SOF can be considered to be zero emissions. It's not entirely zero, however. Some carbon gets released from the production process, including, amongst others, the transport of the feedstock and the refining of the fuel. These elements of the supply chain are taken into account. As a result, SOF is anticipated to provide up to 85% reduction in overall CO2 life cycle emissions compared to Jet A1. The exact level of CO2 reduction depends on the feedstock and the production method. The SOF currently purchased by Air France-KLM is produced with waste and residue feedstock. It can lower carbon emissions between 70 and 85%. In addition to the reduction of total life cycle CO2 emissions, SOF can also reduce direct emissions, particulate matter, PM, with up to 90% and sulfur with 100% compared to conventional jet fuel. Reducing these emissions greatly impact local air quality, in particular in areas with a high density of flight movements, such as airports. Sounds amazing, right? So why are we still using Jet A1? That's another good question. And that's because the industry is not there yet. SOF has a relatively short history, and it's not yet produced on a large scale. At this point in time, SOF may not entirely replace fossil jet fuel. It's blended with Jet A1 up to 50%. The worldwide first commercial flight on SOF was operated by KLM, and it dates back to 2011. So far, there is only one facility in the world that produces SOF on a constant basis, and it's still very expensive. That's why KLM, together with a few partners, is building a fully SOF dedicated plant to produce its own. The facility is located in the north of the Netherlands, and it's scheduled to open in 2023. It will be the first and largest of its kind in the world, producing 10 times more fuel than the current volume available. It will use only residual waste and waste streams from regional industry as feedstock, such as cooking oils. The role of Air France-KLM is to source a large part of SOF from this facility. This could be the first step of really scaling this industry. However, we will not be able to scale it on our own. Support from companies and other airlines is a must. To facilitate such collaboration, we have now in place a corporate SOF program.